Like we said, I mean, I showed you before, almost 96% of an oil is hydrocarbons, basically. And it's a complicated mixture, and every region and every country has different qualities. There are no two crude oils alike, and even within the same oil field, you'll see different qualities of the oil, and over time the oil will change in its quality. So the word crude assays, it's a way to describe the qualities of a crude. This is the second time I missed out. I have an example on my desk, I forgot to bring, of what is a crude assay, which is all the work that goes into analyzing and describing the qualities of a specific crude. And it gets more complicated if the crudes are these worldwide, internationally known crudes, like the Saudi crudes, for example. I mean, Saudi Arabia produces 11 million barrels of oil a day. Remember I said globally we produce about 75 million. So you can imagine how much oil they produce. And so the Saudi crudes, they have a Saudi light, medium, and heavy crudes are well known worldwide. And so they have a very elaborate crude assay workup. So a crude assay describes the different crudes, the types. As I said, a crude oil does change in quality, and then there's always new crudes being discovered. Every time they drill a well, the crude comes out, it's got different qualities. And so you need to analyze it and specify the properties in order to be able to put a value to that crude. So we use the crude assays, this book that describes the qualities of a crude, to define its properties, and that will dictate how I store it and ship it. It describes the value, you know, how do I price it as a function of its product structure, quality of products, as there's some graphs that will show the variety. Define processing requirements, you know, does it have too much light ends, too much heavy ends, and how do you process it, and the composition of a refinery that will process these oils. And then it certifies the crude for the manufacture of certain products. Not every crude oil you can use for producing lube oils, for example. You need very special quality oils for producing lube oils. And the same thing with asphalts and asphaltenes. Not every crude oil will produce a bitumen that I can go and use for paving roads and asphalt shingles and things like that. You need very special, types of crudes that have the qualities. And then again, we need to monitor the quality of the crudes on a daily basis. The refiners actually get a blend of different crudes, and they blend it in such a way that they try and keep a consistent recipe so that I can keep all my units full. Because if you've invested in these assets, billions of dollars that go into designing and building a refinery, you want to make sure you're paying back your investment. And in order to pay it back, you have to make sure all the units are full so that you're utilizing that investment to the maximum ability. So a crude oil, this is how I produce this crude assay information package that I told you about. And it's basically a book that has all the qualities of a crude oil. So they take a barrel, run it through a laboratory that evaluates all the different products, and it produces what is known as an assay program. It goes all the way from how do you explore it and produce the oil, to how do you ship it with the different properties of the crude, how do you manufacture, if you run this crude oil through different processing schemes, what kind of products do you produce and the qualities, what environmental issues are associated with this crude, and then shipping and like S&D. I think it's, I need to look up that word, what do they mean by S&D. Some of the characteristics now of the whole crude as a whole. You've got properties, for example, gravity, and as I said, we measure it by this interesting unit known as API degrees, and that goes into pricing the crude. The lighter the crude, so crude oils that are in the 30, 40, and 50 API gravity are very light crudes. Those will have very high values of the $60, $70, $80 a barrel. The viscosity, is it easy to ship? If the viscosity is very high, that's more indicative of a heavy crude. So you'll see that the prices come down. Sulfur content, I think, is very important because the products and the quality of the products will then have these sulfur components, which means I have to process these products a little bit more and invest more money into producing these finished products. So the higher the sulfur, the more processing and environmental requirements I need to process this oil. Carbon residue, which is the heavy end of a crude oil. And that really gives me an idea about how much asphalt and heavy fuel oil potential do we have in the oil. And then you're left over with some special things like salts and nitrogen and minerals, nickel and vanadium that poison the catalyst. And it's important that we know that beforehand so that we can specify types of catalysts that are resistant or that can be rejuvenated in order to be able to process the oil. And then the light hydrocarbons, even though it's an interesting one because oil normally comes out, especially when you find a new well associated with gas. You always find gas with oil because oils are found, the soil is actually like a porous soil and it fills the pores. And so when you drill a hole, they're always trapped. And oil will always, you're always going to find oil trapped between a layer of gas on top which pressurizes it and then a layer of water down below it which also helps push the oil up. And so you will see all the time that we're always trying to inject gas into the formation to keep the pressure up. And the gas and the oil actually form, I don't know if you guys have played with Pepsi and Coke and carbonated hydrocarbons where we dissolve carbon dioxide into pop and Coke and things like that. But if you shake it and let it go, what happens? It bubbles and it's just pouring out, right? So the mixture of the oil and the gas produces a blend that has a lighter density because it's really the average of the gas density and the water density. And what that does is it helps it boil up and it comes out of the ground and helps it come out. So it's easier to lift, okay? And so you always get this blend or mixture of an oil and a gas in any production facility. Up in Alaska, we produce so much gas and we can't burn it. We re-inject it. So we separate them and we have these big, huge compression stations. That's why we have all this compression. So all the time when you're working on Alaska projects, they're always talking about these big, huge compressors because we have to re-inject all that gas back into the formation again to keep the pressure on the oil, so you're always producing that oil with the gas again. But it comes back up again. So but because we have this gas, these platforms, those pictures I showed you earlier on, sometimes you can't burn it and you can't inject it back into the well. So what they'll do is they re-inject it into the oil and ship it with the oil. And so on the receiving end, these oil companies end up getting this oil that all of a sudden has what they call, you'll hear the term, spiked with condensate. Produces a condensate off the compressors. And what do I do with the condensate? It's liquid. It will dissolve in the oil, so I just blend it with the oil and ship it with the oil. Okay? So you always have a little bit of lightness. Getting back to the specific gravity, so generally it's a measure of a gravity of a component. A lot of you probably understand in like the gravity of water. Specific gravity is really a ratio. It has no units. And what it is the ratio of basically the weight of a fixed volume, whether it's a liter or a cubic foot of the oil or a hydrocarbon or anything basically, related to the weight of the same volume but in water. So that's why hydrocarbons have like a 0.8 specific gravity. Okay? Bricks will probably have maybe I don't know, 5 or a 6. Some of the heavier components, like mercury, has a specific gravity of 13.7, something like that. So 13 times the weight of water. That's indicative of how heavy it is or light. And then that's the formula for the API gravity. So I've given you the formula. My curiosity ages ago was, why 141.5 minus 131.5? And when you look for the answer, actually there's some interesting stories about where that came about and how do they measure it. Okay? And that's your assignment. Then, quickly going through typical crude gravities. Water, you see the gravity is a 1, and the API because if you apply 1 to that formula there, you're going to find out it's 10. San Ardo is a type of a crude oil, a Mexican crude oil, and that has an API gravity of 13. That's really a low quality oil. These are all lower quality oils. Tijuana medium oil, 0.9159. So you can't remember a number like 0.15, you know, it's too complicated to remember. But if you tell me it's a 23 API gravity, immediately I can relate that to so many things. Light Arabian, you know, 0.8586 is 34 and a half. And remember that number because around 32, 34, it's considered light crude. So these are good crudes. You will have a high value for it. These will go for the $60 and $70 a barrel. Okay? Now these lower crudes like San Ardo and Tijuana, and I'll show you in a minute, because it's a heavier crude, it's got more heavy ends in it, which has a low value, and that's why these are rated at much lower value. And then the Mid-Continent and sweet, that's really a sweet crude. 40 API is a very light crude. These are different boiling ranges for these crudes and the gravities. So what we call intermediate, different boiling ranges and the API gravities. We can move a little faster through these slides. Here's a composition of a typical oil, and you can see this is light Arabian crude. And we specify each, what we call a cut. Remember the LPG up on top, that's 4 volume %. And that's all the oil that boils up to 120 degrees. And then the gasoline up to 380 degrees. And then the kerosene, jet, and then diesel up to 650. And then gas oils, heavy gas oils up to about 1,000. And then asphalt is the 1,000 plus. That's really your asphalt product. These are different crude oils. You remember I was saying different crude oils have different mixes. And look at the amount of resid, typically because that's the lowest value. So this will probably have the higher dollar value, and that will have the lowest dollar value because you're buying a low quality oil is what it amounts to. And that's Arabian heavy. It's got 20% resid, which is things that boil above about 750 degrees. Another way also from the crude assays, they break it down by different components. Up on the right-hand side, this should have been colored paraffins. Okay, and then you have naphthenes, which are these rings, but they're saturated. This is all still saturated. And then you go into the aromatics down below, and then the polyaromatics, or the much more, which is asphaltenes. And you can see different crudes have different qualities. Distribution of world crudes. Intermediate crudes pretty much represent 60% of the oil. Naphthenic crudes, 11%. Now, naphthenic crudes have a very interesting property, actually, is they produce a very special kind of coke that goes into making anodes, what we call anode-grade cokes. And there's a few of these crudes that will make anode-grade coke the first time. And this coke, just to give you an idea, will go for probably $700-800 a ton. Regular coke produced from these intermediate, all these other materials, will go for maybe 10, 20, what we call the petroleum coke or power grade. They use it for power plants and so on. And the reason is because naphthenic crudes has very low sulfur content, while the intermediate crudes have very high sulfur content. So that sulfur ends up in the coke, and the coke then has low value because you have to process it and you have to treat the flue gases and so on. These are different properties of different crude oils, all the way from the barrel all the way to Arabian heavy. And you can see the API. But even though the API seems to be getting lower, look at the sulfur content. Sulfur weight percent, 0.42. So Arabian heavy goes all the way up to about 2.8. There's large volumes of Arabian heavy, but then the value, that crude oil, if the market today is at 58, 59, Arabian heavy will go at maybe about $40 a barrel, because it's a heavy crude and it's got too much sulfur in it. This is another way of representing our crude assays, and you will see there's two boiling point curves there. One is a function of weight percent, one by volume percent. In the old days, we used to measure by volume percent. The ASTMs, which is the American Society of Testing Materials. And you need to, it's a very important institute that devises all these testing procedures, and it's basically a procedure for measuring the qualities of so many different products. Okay, and it covers a wide variety. There's about some 20, how many volumes are there now? There used to be about 20 volumes. The hydrocarbons alone, I mean, it's not just refining applications, it's got a lot of other applications to the ASTM standards. At least 2 volumes of them are just dedicated to testing procedures for petroleum products. Okay? In the old days, we used to actually plot the boiling range from 0 to 100 volume percent against the boiling temperature. So you boil some and you measure the temperature, you boil some more and you measure the temperature, and you come up with a curve. Now it's getting automated, and so we have what is known as simulated distillation, which actually uses a weight-based. So it's important for the guys in process to know the difference, because when you get these tests, you have to know, well, okay, that's a test, but what type of test? And then when you get into the heavy end, a lot of these components would crack into smaller and lighter components when you boil it over certain ranges, like 700 degrees. So we have to apply tricks, like basically lowering the pressure as you boil it, and then make adjustments to what the boiling temperature is to be able to produce this complete curve. And then we plot it against the gravity, the API gravity. And this is critical when the engineers are trying to simulate and model the product qualities and these oils in designing crude units and atmospheric distillation towers and vacuum towers. So this is really one of the key data points that we use for designing refineries. That's another breakdown of the different hydrocarbons, and you'll see there's always looking for this, what we call a PONA analysis. It's paraffins, olefins, naphthenes, and aromatics. Obviously there's no naphthenes in here, so it's just PNA, and that gives you properties of typical straight-run naphtha. Now look at the octane of straight-run naphtha. This is the naphtha, or the gasoline components, that come straight off a crude unit. Okay, that's present naturally in the crude oil. And you see, look at the octane rating is somewhere between 40 to 60. You can't sell that. I mean, you put that in your engine, it'll be knocking all the time. You'll be complaining. You'll think there's something wrong with your engine. There's really something wrong with the fuel. Okay? These are jet fuels. I mean, one of the components, kerosene and jet fuel. Kerosene, as I said, is used in lighting. And there's a funny test they use here, the smoke point. And it says minimum there, it goes like 18, 19 to 22. And what that is really, these are in millimeters, and it represents the height of a flame, because kerosene was used for lighting. And you've seen these little kerosene Bunsen's, and it has a little wick on it, and you turn it around and the wick goes up and down. As the wick goes up, the flame kind of gets bigger, but then it starts smoking on you. And you shorten it down until it stops smoking. And that's really the height of the flame, you know, on a wick, basically. And what's the significance of the test is that it tells you how much impurities are in this product. Okay, so the lower the impurities, the higher, you know, it goes up to 22. So that's a nice big flame. So there's a lot of light. Okay, and that's the way they test. And that's actually an ASTM test. So that test is described. You'll see the instruments that are used in measuring the flame test. And then, of course, we look at gravities and sulfur. Sulfur is not very key here, because jet engines burn their fuel way up there in the sky. Nobody, at the moment, the government hasn't been cracking down on jet fuels. So you'll see that jet fuels don't take too much treating in a refinery. We just take the cut and you get what you get. Okay? Altering crude fractions to meet product specifications. These are different specs, like Arabian crudes, and again, this really comes off this table I call that specification that tells you if you change the volume percent, and basically what they're playing around with is up here on the specification, you're cutting from 380 to 500, 330 to 500, and then more 380 to 500 in different crude Jet 5 and Jet 8. These are specs of that product. One of the important things with jet fuel is freeze points, because you ever seen those screens that come out and tell you your altitude and what have you? There's a temperature. I don't know. Has anybody remember what temperatures does it run up there? It's pretty free. I mean, you're down below 40 degrees or so. So if your fuel freezes on you, of course, you won't have fuel going to your pumps, and you won't be able to pump the fuel. So it's a critical specification for jet fuels not to freeze at these high temperatures. Okay, so that's really an important specification. Light fuel oil potential for crudes. We look here, aniline point is a measure of how much aromatic materials are in there. Diesel indexes are important. Diesel index, again, is similar to octane ratings. So, but in diesel engines, because diesel uses a different mechanism for firing, those of you who have a mechanical background knows that there is no spark plugs in a diesel engine. We use the compression to raise the temperature high enough that it will ignite the fuel. And by doing that, you actually get a much wider range of power recovery from a diesel engine. So even though, I mean, these days diesel looks or appears to be more expensive than gasoline, but diesel engines does have a higher energy efficiency compared to gasoline engines. I don't understand why it's not very popular here in the States, because you go to Europe and I would say maybe what, 40% of the cars are diesel engines maybe? I've had a funny story. He's not here, so I can tell the story. A friend of ours, he went to England, rented a car, ran around town, and went around England touring, and he ran out of gas, went to the gas station, filled up the car with gasoline, came to turn the engine on, the engine wouldn't go on. That's when he recognized, or he called AAA, of course, to come and check the car. So what's wrong with the car? And the first question the guy asked is, what did you put in your car? So, well, I put gasoline. He said, what model is it? He told him the model, and he says, yeah, that's a diesel engine. It's not a gasoline car. So you couldn't put gasoline in a diesel engine. It just would not fire up. Okay. And again, so when you ever go rent a car in Europe, make sure you know what kind of fuel. They don't have the nozzles like we have here. I don't know if you've pulled out a diesel a nozzle with a green on it. I don't know if you notice they're labeled differently. But the diesel nozzles don't fit in a gasoline, it won't go in. So you can't dispense diesel in a gasoline. So they're a little smarter here in the States as far as dispensing gasoline. Part of it has to do because we have to put those bellows. You know, you have that big fat rubber hose that goes over the nozzle. And what that is doing, I'll show you later, is that it sucks the gasoline vapors so that the vapors don't go into the atmosphere. So when you're actually pumping the gasoline in, it's sucking the vapors out because the vapor is being displaced by the liquid, and so the air is sucked into a vapor recovery system that's in the station to minimize emissions. So that's important that you know that. These are heavy fuels, different types of crudes. You can see the numbers, they're not identical. You have different pour points. You have different. A pour point is a funny test that you fill a tube and you cool it, you keep cooling it, and you tilt the tube. If you see the fluid still pouring, then you still haven't reached the pour point. You keep cooling it until you get to the point where you can't pour it anymore. So you can see, like at 100 degrees, you can't pour Light Arabian crude, so this Nigerian crude, which means at 100 degrees I can't pump that stuff. So you have to heat it in order to be able to pump it. Okay? Same thing with viscosities. You have to watch out because we use that a lot in moving these liquids around. Heavy resid, now you're getting really into heavy materials. We look for qualities like concarbon, metals like nickel and vanadium. And the reason is because we use a lot of catalytic processes for upgrading this resid. So the more nickel and vanadium you have in an oil, the more susceptible the catalyst is for poisoning. What happens is the catalyst, and there's some later lectures that we're going to arrange for you that will describe what is catalysis and how does a catalyst work. It's got little pores on it, and it's got these active sites that have the special metals on it. These metals have a tendency to deposit on the catalyst and basically plug it up, so that then you're not getting the reactions that you're supposed to get. These are asphalt potentials in crude oils, and one of the tests that we use is this penetration test and a softening point. Asphalts are used in paving in streets, so if the temperature, the ambient temperature gets too hot, softening point, what happens? At 110, 120, you try walking in an asphalt, and you probably feel it sometimes. You're walking, especially with high heels, you find out you're going right through the asphalt. Okay? So these are properties that we need to watch out for. Product qualities for motor, gasolines, and distillate fuels. So we're going to take each different product, like gasoline. These are essential products. Now today gasoline is controlled by the government. The government specifies the qualities of the gasoline. And one of the problems we have in California, I think we'll discuss it, I'll get to it. So we look at octane qualities, because the octane numbers and ratings are important for the value and the price of octane. We look at the volatility. These motor gasoline engines actually use spark plugs, and so the volatility of a gasoline is important in order so that the spark, ignites the fuel. Oxygenates. There's an important. It's got a lot to do with the emissions of a fuel. And then additives. I was up at the Valero refinery. We were working on taking MTBE out of gasoline. I don't know if you all remember, a few years back, one of the ways of adding oxygen into a gasoline component was adding a chemical called MTBE, methyl tert butyl ether, that had an oxygen content of about 2–8%. And we blended it with the gasoline. And so we were putting in these blending equipment, and right there, this is a Valero refinery, right? And we go up to the area where they're shipping all their gasoline out to all the different users, and there's these little additives, tanks, that had BP, it had Chevron on it, it had Unocal 76, and it had what it meant is that each oil company had their own additives. You go buy Chevron with Tekrolin, you buy super this and super that. These are all buzzwords for little additives that they add. Basically, they're detergents that help keep your engine clean and lubricated and managing. But they're injected in very small quantities, that each individual refinery produces all these different qualities of gasoline, and also sells the gasoline to Chevron people that buy Chevron and buy Arco and buy. So I always get asked this question is, I find that gas station has better quality gasoline than this other gas station. And in my mind, being a chemical engineer, to be honest, with the specifications now that each refinery has to make, the blend is so tight that they're all pretty much the same. So an 87 gasoline sold at the Arco station is pretty much the same as that sold in at the Chevron station. The only difference, they add little additives, these little small additives in parts per million, plus they add a little color here and there just to differentiate the qualities of the gasoline. So if you ask me, which gasoline do I buy? I said, I buy the cheapest gasoline. Do you buy 87 or 91, 92? This has to do with tuning your engine. If you have a high-performance engine like a BMW or a Mercedes-Benz or something like that, if it's tuned to that fuel, you have to put that fuel in. Of course, if it's tuned to a 91, 92 octane, you better put the 91, 92 octane. But if you're going to tune your engine, You can put an 87 in there, tune it to the 87, it'll perform just as good as a 91, 92 octane. Okay? So, as I said at the end, it's an economic question. Whether you can afford the 91, 92, then, use the 91, 92. Distillates, these are aviation fuels, diesel fuels, and residual fuels. I'll go into a little bit more detail. Let's go through it. Yeah.
On the fuel, is it stable? Is the octane stable in your tank of your car?
Octanes, I said that last week, really. As I said, look at this composition here. Here's gasoline blending. A refinery has a reformer, it's got an FCC unit, it's got an alky unit, it's got an ISOM unit. These are specific units that take